you through what is HDFS and MapReduce, and I'll be taking all your questions at the end. Okay, let me first finish the slides that I have, and I'll be taking your questions at the end. Okay, hopefully that works. And in spite of me having clarified all your doubts here, if you still have further doubts, I'll tell you where you can contact. Okay, I'll give you all those details as well. Okay, there you go. I hope I'm loud and clear. If some of you folks are not able to hear me, do let me know. Okay, if there are some disturbances on your side, my side, if you're not able to see my screen, not able to hear me well, just let me know, and I'll try to sort it out for you. Okay, so now here we go. My name is Chogendra, and I have been working in this industry for a very long time right now. It's been a decade and a half already, and I have worked in various tools, technologies, name it, and I would have worked on it. And also, it's been more than 5 years in big data and analytics. I'm very passionate about learning. I love technology. That has been my forte. I have designed, architectured many an application and program. I'm a very keen learner, and I have been working with big data analytics. Name it Python, R, just name it. In the ecosystem of big data, I've worked on it. So there you go. The objectives of this session are. First will be an introduction to big data and Hadoop. Some of you would have already heard about big data and Hadoop, right? It's the buzzword right now. Everyone wants to know big data. Everyone wants to move to big data because it's high paying, right? Industry is paying quite a lot of money in order to get skilled big data resources, and they are not getting it. I mean, there is a stark difference between supply and demand. There's huge demand of big data experts, but then there is limited supply. And even when we find such resources, which I have seen in my personal experience, even when we find them, they're not that good enough, and so we don't hire them, right? And how is it that you can be a notch higher than the rest? I mean, how can you differentiate yourself amongst many public, right? Many people who are learning big data. So I think will help you solve the problem. So that's the session objective: understanding HDFS, Hadoop Distributed File System. That's the second topic in my session objective: understanding MapReduce with example and scenarios. Okay, so I don't claim to make you understand completely, give you thorough concept of MapReduce in just 1 hour of technique session, but I can definitely guide you as to where you can head, and I mean which route to head, so that you can learn and understand MapReduce better. Getting answers to interview questions on Hadoop. So this has been my experience. Yeah, my personal experience has been we ask only a few basic questions whenever we are interviewing, and we expect very simple, straightforward answer. Okay, we do not expect you to be very expert on the questions that we ask, but then we expect you to be thorough on whatever you are asking. Let's say, for example, I ask you as to what do you know in big data, right? And then you say, I know Hadoop, I know HDFS, I know MapReduce, I know Pig, I know Hive. And then the second question I might ask you, how good are you in Hive and Pig? You say, I'm good. And then I ask you, how much do you rate yourself? You say 9 out of 10 in Hive. And then I ask starting questions on Hive, right? So it's then you'll have to set the expectation straight. If you say, I know 9 out of 10, you have to be very thorough on the subject, because if I'm on the other side, I would expect you to be extremely good if you say you're 9 out of 10. But then if you say I'm 7 out of 10, and then I know the concepts and I've worked on this specific task, then it gives us a very clear picture of what you have understood, what you have learned, and based on that we can ask you. So our expectations are not that great. It's just that you have to set the expectations straight, and eventually getting your doubts cleared. So big data and its challenges. How the big data project coming along? Okay, you can look at the cartoon and it's quite funny. But all it's trying to depict here is you have huge pile of data right now, right? Everyone has data. Any company, be it IBM, be it Dell, be it Apple, Google, they all have huge set of data. I mean, how do we leverage this data in order to design an application which is intelligent? How do we leverage this data in order to help our business? Let's say, for example, I'm in retail industry. How do I leverage the data? Let's say I'm Walmart, right? I have 20-30 years of data with me, right? Let's say I sold something. I sold some grocery of 10,000 USD. Let's say some floor, right? 10,000 USD in 1970, and there has been steady growth year on year on that on floor sales in my particular shop in particular location, right? How do I look at the pattern and try to leverage on the existing data that I have with current tools and technologies, be it massively parallel processing system? You might think of Oracle as a database, MySQL, SQL Server, DB2, MPP, IBM's massively parallel processing system. They are still inadequate. I mean, I have seen this. I have worked on. I have by looking at my experience, you would already know that I would have worked in many places, starting from multiple MNCs to startups to everywhere. I've just worked everywhere. So what I have seen is over the past 15 years is that people don't tend to use the complete data that they have, right? Let's say we have data for the past 30 years, but in order to do our forecasting, all we do is we take our 5 years data and do our forecasting, right? It's so bad when we have 30 years of data lying with us. That's a gold mine, right? We can mine those data. We can pull out various information, do n number of analytics, and then help our business. But then, because of lack of tools and technologies, we are not able to do that. But that was until the advent of big data. Even now, even after the advent of big data, there is a buzzword across the industry, right? And then they say that big data is the discovery of electricity. I mean, the impact of discovery of electricity in 19th century had a profound impact on humanity. We started looking the world in a different way. So they say that experts say that the advent of big data is bigger than the invention of electricity. I mean, that's a huge big statement to say, right? But then we say that, and why do we say that? But then this is what I've seen. Okay, I hear people talking about big data, but they don't know the implementation of big data. They don't know what's big data. They just talk about data. They know there's a lot of data, but how do we process the data? How do we mine intelligence out of it? How do we make intelligent programs? How do we do analytics on it? No one knows it. When I say no one, I don't mean to say Google or Facebook does not know it. They are doing it. Google, Facebook, Yahoo, the big 4 or 5 are doing it. I mean, they are doing it very well. But all of us are playing the catching game, right? We are still trying to ape them. We are still trying to see what Google does. Basically, the whole concept of big data came from Google File System, GFS, and then eventually it became Hadoop Distributed File System. I'm going to talk about that in some time from now, but I'm just giving you a background, right? I mean, we talk about Amazon Web Services. We talk about all cloud, right? Everyone talks about cloud. There are many funny videos, being viral in YouTube as well. But then, how many of us do actually understand what is big data, what's analytics, what do we talk about, cloud as a service, etc. We hardly know any of those stuff. And most of us, I would say at least 70 to 80% of the firms that are working on big data right now, they claim to have big data solutions, are just playing catch-up games. I mean, they themselves don't know as to what they are looking at. I mean, I can share an instance with you wherein I went to an interview and the interviewer did not know what to ask. Right? I was like, seriously, you're asking me those questions? And I gave him a feedback saying that if you're calling people of my experience in your interview, please have someone who can, at least provide me some knowledge or even ask some kind of intelligent question. I mean, don't ask me these basic questions that you are used to asking everyone. So that's the feedback I gave. Okay. So moving on, who generates big data? Right, everyone. Everything generates big data. It's not just Google, Facebook, or LinkedIn. Okay, it's the satellites that we have. It's the submarines that we have. It's the TV shows that we have. It's the mobile phones that we have. I mean, just take a name and that's generating data for you. It's the weather forecasting system that we have. It's the robot that we send to Mars that's generating big data. Everything, just take a name and that's generating data for you. The RFIDs, they are all generating huge amount of data. So I'll give you a trivia. Till last year, the amount of data that was generated till last year, I don't know, it was some, what was it, petabyte, zettabyte, I think it was in petabytes, okay, some 2.7 or something petabytes till last year. But then from last year to this year, that has gone on to increase 10 times, and they say that in coming years, that amount of data will be generated every day. And that's for, let's say, next 10, 15 years. After that, we'll be generating petabytes, exabyte of data every day. How are we going to process that amount of data? Is it possible to store that amount of data in, let's say, Oracle? Even if they scale up, right? It's Oracle or DB2 or whatever. Even if they scale up, think about, the data that we have. It's not the table structure, right? Employee ID, employee name, age, sex, etc., etc. That's not data, right? That's all in structured format. You have data, okay, fine. But whatever the text data that we have, whatever the tweets that we have, whatever the Google searches that we have, whatever the text data that we have, are they not data? Do you not want to store those data somewhere? Are pictures not data, right? Are signals not data? I mean, are movies not data? What is not data? Everything is data. And what is it that you need to store this different type of diverse type of data? You need different databases to store that. Right? Some might store some data in MongoDB, some might store in HBase, some of you might store all this text file in your hard drives, some of you might store in cloud, some of you might actually store it in, let's say, at DB2, Oracle, at whatever, I mean, MySQL, SQL Server. So it has to be a combination of all these data bases. One, it has to be a combination of databases, all different types of SQL, NoSQL, columnar, all different types of database, plus your non-databases like maybe flat file, so on and so forth, right? The data has to be a combination of everything, and when you want to generate intelligence out of it, you have to take everything into consideration. Let's say, for example, last time when there was election in US and even in India, social media was used very effectively, right? Someone was tweeting about Indian Prime Minister or even Barack Obama, US President, and those tweets or Facebook chats or your blogs, they were collated at real time. We were pulling those data real time. I myself did the analytics on one of those. We were collating those data runtime and using big data, and then we were doing sentiment analysis. Okay, when I say sentiment analysis, I was like, what is, let's say, for example, I mean, whether people are talking good or bad about a certain person, right? And then we were like, okay, fine, people are talking good today about XYZ, right? And then the next day, no, because of this particular instance, people are not taking it correctly. And then we used to give our feedback to the concerned team, and then they used to take it from there and then type their speeches, whatever, in the languages that they want, right? It's extremely interesting. It's beautiful concept. The deeper you go, there are more chances that you might be lost in the whole ecosystem of data there. You might get lost in big data. But then when you eventually come out of it, you'd be a changed man. You'd learn to look everything from an opportunity perspective. When I look at Facebook, when I look at Google, when I look at Twitter, I see that as an opportunity. I mean, there are immense, but I mean, just look at the number of startups that are coming up every day, right? Are they not using big data? Most of them are trying to leverage one or the other data set that they have and build something on top of that. Now, even if they are not today, tomorrow they will need to scale up, and when they need to scale up, it has to be through big data. Otherwise, you are doomed. You are setting up yourself for failure. Okay. And it says, right, it's so aptly put here. Today, it's becoming a problem for all of us to manage big data, right? Even in your home, just think of ways in which you manage your movies and music. Let's say you have 10 gig of movies and music. That's fine. You're able to store it in your hard drive. Slowly, it goes to 100 gig, and then you say, okay, my hard drive is only 200 gig. I need to buy one more hard drive. Let's say your data grows to 500 gig, and then you say, I need to buy 1 terabyte. I mean, how much can you go further? How much can you keep on adding hardware? At a point in time, we'll say, I give up. Either I cleanse those data, or I need to find a source in order to store this data. Or maybe I need to zip this data and store it. I need to compress this data and store it. You will start thinking in so many number of ways, right? So that's about big data. Big data is not just about data. It's not just about the volume of data. We have 3 V's definition of big data called as volume, velocity, and variety. Okay, there is 4th V as well. We'll come to that. Okay, which is called as veracity. I mean the correctness of data, which I'm not going to talk right now. We'll only be talking about volume, velocity, and variety. What do I mean by volume? When I say volume, it can be as big as 1 gig, 2 gig, 1 petabyte, 1 zettabyte. That's volume, right? It's a measurable quantity. When I say variety of data, I've talked about the different type of data, right? Text data, movies, music, so on and so forth. Just think of any data, RFIDs, your signals, whatever it is. They are all variety of data. And velocity. Even if you have a petabyte of data and then it does not have a sustained growth. Let's say, for example, I have 1 GB of data today, and in 10 days it becomes 2 gig, 20 days becomes 3 gigs. There is a growth of that data, right? If you look at the trajectory of growth of that data, it is consistent. If you do not have a consistent trajectory of growth of your data, we do not call it as big data. It's just a data at the end of the day. So the definition of big data is 3 V. So if someone asks you what's big data, you always remember 3 V. It's volume, variety, and velocity of data is what it makes big data. Now I'll add the 4th one, which is called veracity. Okay, you just cannot have any data called as big data. It has to be proper data. The English translation of veracity is you have to be able to prove that it's the right set kind of data. So veracity was added very late, right? But then initially it all started with 3 V's given by IBM, and then it went on to become 4 V, wherein they also check the veracity of the data. So moving on, Hadoop can be used for easy processing of such huge data. How, right? That's a very big question that I've asked. Okay, I mean, how? Now the next question that would come to your mind is, I've talked about so much of data. I've talked about simplifying the data. I've talked about processing the data, bringing out proper analytics out of it, helping the business, creating more opportunities, creating more jobs, and making the world a better place, right? I have talked about so much thing in such a short span using big data, but how, right? How do we do it? But before we go on to that path, let's understand what's Hadoop, okay? And then I'm going to explain you as to how we are going to solve all the problems related to the world using big data, okay? Before I even venture out into that, I was reading an article on the advancement of medical technology, okay, using big data, of course, right? Therein, I think this is already out, and human trials are going on this, okay? I'm not sure about, I cannot verify the accuracy of this report, but then I know for sure that there is there is a lot of R&D going on this. So what this medical company has designed is a chip, okay? I'm sure some of you would have already read about this. So what they are going to do is they are going to insert the chip inside your body, and there will be a central server somewhere in hospital, nursing homes, wherever it is, right, which will monitor the vital statistics of your body. The chip will at any point in time, every second, will emit your vital parameters like your BP, your heart rate, your so on and so forth. There are so many things. I'm not a medical person. I don't know, right? It's been some time. I've read that article, so I don't even know. There are so many vital parameters, right? If and I know blood sugar level or so on and so forth. Okay, so many vital parameters. So this device is going to emit continuously all your data. This data is going to be fed remotely into a server somewhere, and then it will keep on. There will be some big data engine which will be running in the background, which will run on your data every day, day in and day out. And you know what? So on a parallel track, right? Even before going to this particular example that I'm giving, you know, when a person's body has to go through heart attack, right? Your body starts emitting certain toxins. It starts behaving some unusual behavior 24 hours in advance. Okay, it's a medical proven fact. So let's say, for example, you are about to go through a heart attack, right? Your BP will function in some abnormal way. There will be some other toxins which your body will release in order to preempt that, right? I mean, our body is a wonderful machine. It tries to preempt everything, right? If it is going through BP, it will do in order to safeguard itself. If a virus is attacking, it will produce antibody and try to attack it further. So it will try its best to stop it, right? But when it cannot, it is when your heart fail and heart attack and also sort of thing happens. So using this chip, as soon as your body starts behaving in erratic fashion, there will be someone, you know, this big data engine will throw an alarm. Okay, it will start giving an alarm. It will start raising an alarm saying that this person is about to go through a heart attack. Okay, his body or his functions, his hormones are behaving in certain erratic manner. So even before you have an heart attack, 24 hours in advance, a paramedic will be at your doorstep. They will take you there. They will treat you, and even before you have a heart attack, your life is saved. So this is going to transform the way medicines or you know, medical history has come up. Okay. So the point here I'm trying to make is big data is going to change the way we live our lives. It's going to save many lives. Now let's understand. That was just one example. Let's understand what's Hadoop. Okay, Hadoop, and now I have given you all the big examples and stuff. Now let's go to the basics. Back to the basics, right? What's Hadoop? What are its characteristics? I see that some of you already have questions. I see my chat window popping up, and then it says you have questions. Just give me some time, folks. I'm going to take your questions definitely, but let me walk you through some of the slides and then take your questions. Apache Hadoop is a framework that allows the distributed processing of large data sets across clusters of commodity computers using a simple programming model. Now this is just theory, right? And this is just good words put together, right? It's a beautiful sentence. What does it actually mean? So okay, let me explain it to you in this way. Right now, I'm sure most of you are working in a very good place or in big companies, in startup, whatever it is. I mean, all of you must have heard about one thing in common, right? The server went down. We have a server, we do not have space. There is some problem in the server, or the server is not able to take so much of load. You know, that's too high processing of CPU in server, or there's let's see, we have to increase the memory in servers. Something is happening to the server. I mean, anything that's related to server, all server, right? So I've been hearing this all my life. Okay, server has this problem, network issue with the server. There's so many other problems. So basically, when I talk about Hadoop, and okay, next question. I mean, how much this server cost? Who sells the server? Who creates the server? I mean, why are the servers so powerful, right? So basically, servers, IBM, Lenovo, HP, Dell, they make the servers, and each of the servers cost at least $1 million. You know, I'm just underestimating the dollar value here. $1 million is nothing when it comes to a server. You know, you just get the basic version of it. So it costs $1 million. But for an ordinary folks, let's say I want to open a company. I mean, I'm a poor man. I don't have so much of money. I mean, I cannot invest $1 million. So will I still not open a company? I mean, will I still not create a product? I will, right? I have to find a workaround for that. So Now let's see how Hadoop helps us. Okay, and if not everyone can afford $1 million, right? So basically, Hadoop is a software which you can install in any commodity hardware. I cannot afford a $1 million server, but can I afford 20 normal desktops, which cost around let's say one desktop cost around 1,000 USD, or if in terms of rupees, 50,000 rupees, right? 1,000 USD. Let's say I want to buy 20 desktop. 1,000 USD, I mean 60,000 rupees. I can buy a very powerful desktop. Okay, I know that. With $20,000, I can buy 20 laptops or 20 desktops, and when I wire them together, the performance of that 20 computers will be better than that of $1 million server. How? I'm going to tell you that. Okay, that's the beauty of Hadoop. Okay, that's the beauty of distributed file processing. So what am I going to do here is, instead of one server processing 1 gig of data or 1 GB of data, I split this data 1 gig into 20 pieces and give each piece 1 chunk to process. Okay, if I divide 1 GB by 20, how much do I get? I get around 50 MB, right? So 50 MB and one machine which has 16 GB memory, okay, RAM, and let's say i7, is going to process in real good time. I mean, it's just 50 MB, right? It will process, let's say, in 5-10 seconds. And just take that to 20. I mean, 1 gig will be processed in, let's say, even at max, even if it processes in 1 minute in a cumulative fashion, I don't think servers will be able to do that. Even if server is able to do that, look at the amount of cost I am saving by using HDFS or Hadoop, right? It's just staggering. Okay, and the most beautiful part of this is it's an open source. You don't have to pay a single $1 to install this software and start working on it. It comes free. They say that good things in life do not come free, but Hadoop comes free. Okay, and it's extremely reliable. Now you might ask me, right? Your next question would be, okay, fine. You might be like, okay, fine. I split the data into 20, into 50 MB each, and then I process it in each single machine. Okay, but what if one of the machine fails? I'm sure some of you would have this question. So in that case, there is something called as replication factor. Okay, for each data that I process in one machine, I keep 3 machines as a backup. That's the standard procedure that we follow. So if I have to process my data in 20 machines, I will have to keep a backup of those data into 20 into 360 machines. So all in all, I'll have 60 machines. Now you'd say that 60 machine equal to 60,000 USD. Is that still less than $1 million? It's a lot less than $1 million, right? I mean, 60,000 USD is, I mean, it's not even close to $1 million. It's not even 100,000 USD, right? And it's a 10 into 100,000 USD makes $1 million. So it comes a lot cheaper. Okay, so, and when I say reliable, now let me come back to reliable. When I say reliable, if one processing fails, let's say in 20 nodes, right? If one node fails, I have 3 nodes where the same data is being processed. If one node fails, the software is such that it gets replaced by the other one which is working. It's a very beautiful concept. It's extremely robust. Okay, whatever questions that you might have at this point in time, and how does it work? Let's say all 3 fails, you'll have all sorts of calculations going on in your head right now. But then it works for Google, it works for Facebook, it's working for all other major companies. So there definitely is an algorithm which is 99.9% unbreakable. Okay, but even then, I'll tell you as to where Hadoop can be used and why you should not be comparing Hadoop with relational database management system. So if you were to be thinking that can I implement a banking software in ATM software using Hadoop, no, that's not why Hadoop was implemented. Hadoop is not meant to do your online transaction processing system. Hadoop is meant to do your online analytical processing. Now, what's the difference between those two? We'll see that. Okay, I'm just looking at the timing. Okay, guys, I can talk for 10 hours, but then I'll have to do a time check as well. And it's economical. I already told you why it's economical. It's scalable. It's scalable in the sense that, you must have heard this in your company, right? They say that one one server is not sufficient because our business is growing, I need to buy one more server. And have you seen this in any of your company? There is an outage, database outage, this website is not going to work because of this outage, that outage, so on and so forth, right? I'm sure you would have faced this, okay? So the reason why they have this outage is because when they are adding new servers, right, they need to bring down the entire system, join this with the existing hardware that they have, and then bring it up together. That's how it needs to be done. I mean, be it Oracle server, be it any DB2 server, any other server. But in case of Hadoop, let's say I have 60 machines, I want to add 20 more machines. So it's as simple as adding an IP address to a file, and that's it, that's done. You are in the middle of running a program on a Hadoop cluster, and then you think, oh no, I need to add some more machines to it. And then you just go on, open a file, add the IP address of those 20 machines, done, that's it. It's that simple. That's why it's called scalable. And because it's reliable, economical, scalable, extremely flexible as well. You can just play around with it. You can just change the way it's working. You'll understand that. I mean, look at scalability. It's so easily scalable. That's why it's extremely flexible. You can use 10 machines to do a job, one job, other 10 machines to do other job, so on and so forth. It's extremely flexible. So this is Hadoop ecosystem. For those of you who are seeing for the first time, don't get overwhelmed by it. They are all simple tools. Okay, they are simple stuff built on top of Hadoop. If you look at this bottom scoop, right, this is to communicate with the structured database. Let's say I have data in my database and then Oracle data or RDBMS database. Right? I need to pull those data and then process it in Hadoop. What do? I scoop out the data from structured database into my HDFS Hadoop Distributed File System and then process it. Flume is to pull data from unstructured or semi-structured data. Let's say, for example, I want to pull data from Twitter or Facebook. I can use Flume. I need to just pull data from a text file and then process it in HDFS. I can use Flume, so on and so forth. So it's not just this tool, tools. There are many other tools as well. But because of lack of time right now, I'm not going to talk about everything else. Okay. And this is with Hadoop 2.0. It's called yet another resource negotiator. It's a beautiful concept. Right now in Hadoop 1.0, which is most famous and most widely used, there is no concept of hot backup. Okay, if one server fails, let's say name node fails, there is no concept of hot backup, but there is a concept of secondary name node. Okay, in case of yet another resource negotiator, there is a concept of hot backup as well. So which is altogether different concept. We'll have to go into extreme detail for me to explain that, but I'll stop there myself. And then you have MapReduce framework, other YARN framework, and then you have Pig, Latin, and Hive. Okay, I'm not going to talk about everything, but I'm going to talk about Hive and Apache Uji. Okay, just for your benefit. I'm sure most of you so far would have written at least one line of code, right, in database. I'm sure everyone would know select star from table. If you don't know about select star from table, I strongly suggest you read RDBMS a little bit. Take a 50-page book and then read about RDBMS. You definitely need to know you definitely need to know RDMS before you even get into any industry, IT industry. Okay, even if you don't know, that's still fine. Okay, you can still learn it. It just takes 2 days to learn all those things. But I strongly suggest that you at least learn select star from table. And for those of you folks who know select star from table, Hive is extremely easy. Okay, so using Hive, you can connect to Hive is called it's like a relational database itself. It's like an SQL. Okay, we call it as HQL, Hive Query Language, instead of structured query language. Instead of SQL, we call that as HiveQL. Okay, now in that you can use select star from table. You can use you cannot use insert and update. Okay, those are restricted. CRUD operations are not allowed. Not CRUD, only update and delete are not allowed. Update, delete are not allowed. Insert at the row level are not allowed. But then it's extremely powerful. Okay, you can access the database of HDFS. The table sitting here can be accessed using Hive, and you can perform all your select queries, all your inner joins, outer joins, minus, union, everything can be done. So if you know select star, you can learn Hadoop, and it will take you what, a month's time of training, and then you are good with it. Okay, so HDFS and its components. Okay, let me look at our questions. Okay, I've been talking for a very long time. That will give me a breather as well when you look at our questions. Okay, I see there are a lot of questions. Okay, a lot of questions. Oh, Pratik. No problem, Santosh. Actually, I'm BTech 2013 passed out. Is it suitable for me? Murli, it's suitable for everyone, man. Trust me. 2013, I have seen people who were just passed out 2014, trying to learn this. And because you just passed out, right? It's a big advantage for you. You do not have this technology impedance in your head. You do not have this concept of, I know this technology, why do I need to learn something new? So you are fresh. You can just learn it. It's easy, and if you start now, it'll be good. Oh yes, Balaji, you guys are all muted. But in the end, if I have time, I'll just unmute you. You can ask me questions. Anand Krishnan, I did not get your questions. Internet of Things, I don't. I'm sorry, I didn't get what's that. Pratik says, it seems I'm not getting any audio. Try reconnecting twice. I'm sorry, Pratik. I guess there is a problem with your mic. Okay, Krishna says, I think there could be also some analytics on this data which could predict based on pattern of the vitals. Absolutely, Krishna. We are all already doing predictive analysis. We are using all kinds of machine learning algorithms in order to do predictive analysis. The world has moved very far today. All this we are even doing artificial intelligence using big data. So, yes, you are right. Can you give full stack architecture which shows where big data comes? If you just looked into this, right? I mean, this is the ecosystem of big data. Okay, Hadoop ecosystem, Anand Krishnan. Basically, your big data is complete. Big data is not just one tool or technology; it's an ecosystem of tools. Okay, when we talk about big data, it does not mean Java, C, or C++. It's an ecosystem of tools. Okay, can I install Hadoop on my desktop? Absolutely, you can do that, Praveen, but that will be a single node cluster, and you can do it for your own learning. Otherwise, you have these things available in cloud as well. Can you explain Hive again? Okay, Hive is very similar to SQL. Okay, it's called HiveQL. You can fire all your insert, select, update, delete, but internally there is a mapper and reducer, and I'm going to explain what a mapper and reducer is in a short while. But then internally, it does not perform the same way as normal SQL does. It's more of mapper and reducers on top of which SQL has been written. Okay, it's a very interesting concept. You can use insert Ravi in Hive, but that is not at a row level. Okay, you cannot do row level manipulation. But if you want to insert a bulk of data, then it's possible. Yes, on the update and delete, it's not allowed at a row level, because update anyways is at a row level, right? Insert is allowed, Ravi. Yes, you are right, but not at a row level. I am SQL Server plus Oracle DBA and started learning Cassandra. What's your advice? Which one I should learn to enter a big data world, Hadoop or Cassandra? So because you already are an SQL Server and Oracle guy, right? You already know SQLs. I'm sure you are an expert on that. You must be doing performance tuning. You must be doing all those table partitionings, etc. If you learn big data and especially Hive on that, Ashish, you will be able to learn it in 15 days. Okay, that's my guarantee. But then you'll have to be serious about it. Okay. How Hadoop is good for a DBA? Srinivas, that's the same answer that I gave to Ashish. Hive and even Pig, right? Extremely easy for you guys. You'll be able to adapt it in no time. Okay. How about Oracle DBA jobs? Don't you think? I mean, are they hyping anymore? I don't think. And are they not getting saturated? See, I started my career as an Oracle guy. Okay, so I know in and out of Oracle. I've done a lot of performance tuning. I've done DBA activities. I've done everything. So it's been 7-8 years. I've moved out of it. So I have worked on Oracle from 6i to 10G to 11G to 12G. So 12G was the last on which I was working full time on Oracle. Not full time. I mean, I used to know about. I used to read all those white papers and everything. Murli, big data is the thing of this century, man. I am a DB at healthcare industry. Okay, okay, Srinivas, I'm working for Cognos for 9 years. Okay, okay. Raminder, what is good to learn Hadoop for me? I mean, learn Hadoop as a whole first, and then you can bisect. You can see as to what you want to learn on that. So basically, you learn the whole Hadoop architecture first, and then you pick one Hive or Pig, and then you learn one. After you are done with that, you move on to next. It's a continuous learning process, guys. You just cannot say I will learn this and I will not learn the rest. It does not work that way in Hadoop. Okay, so it's different from the conventional learning that we have done. It's different from C++ that we have learned in our schools and colleges, right? It's different from just learning Java. It's and I would also say Hadoop in combination with Python becomes very deadly. Okay. Okay, Ronak, a little bit of Java knowledge is good, but even if you do not have that, it's fine. I did not have Java knowledge when I started learning Hadoop. Oh man, if you are a Java guy, Pranav, it's for you. I think you should start it. Do I need to learn Java? Not necessary. I'm trained in mainframe technology. Okay, I have lots of questions from you guys. I am extremely sorry that I'll not be able to take them all. I'll take you through Hadoop ecosystem, quickly walk you through this, and Pranav, Srinivas, Jaydeep, Balaji, Rohit, so guys, Bibhu, Saurav, Himani. So absolutely, Himani. I mean, if you're open source secure, you can customize it to your own need. Okay, so guys, I am not taking many of your questions. They are all wonderful questions. They are all very valid questions. But because of lack of time, I'll have to just move in a little fast. If you want, you can send us an email on all your questions, and trust me, everything will be answered. Okay. Hive means as ETL. You can use Hive as an ETL as well. Hive, mostly we use Pig as an ETL and Hive to do our data warehouse, but you can use that as an ETL as well. No problem, Santosh. You don't need to know programming. You can still learn, and you can still learn programming. It's no big deal, man. Okay, guys, can you please explain mapper and reducer in detail? Yes. Now let me go ahead and explain mapper and reducer in detail. Okay. Let me try to maximize it. Okay. Okay, fine. Now Hadoop Distributed File System, it's like I told you, right? I've given you a brief idea as to how Hadoop Distributed File System works. Now I'm not going to go into very details about it, but I'll talk about what HDFS is made out of. Okay, HDFS has 5 daemons, okay, which are called as name node, data node, job tracker, task tracker, and secondary name node. Okay, these are the 5 daemons that HDFS has. Now I have not opened my VM right now, so I'm not going to show you that. But then if some other opportunity arises, I'll definitely show you as to how it is installed, how you run your programs, how a big program can be, if something is taking 10 hours, how can you reduce it to 15-20 minutes using Hadoop. It's quite interesting. So let me talk about a couple of daemons. Name node, basically the concept that we have in our head, right? We think that wherever data is stored, right? For all you Oracle guys, SQL Server guys, all database related guys, right? You'll be able to concur with me. You'll also be able to appreciate the fact that whenever we store this data, right? Whenever we create the data, the metadata goes somewhere, the data goes somewhere. If you are an Oracle guy, it goes into data dictionary. If you're an SQL Server guy, it goes into DBC columns, DBC tables, again metadata somewhere, right? Okay, it's not DBC, sorry, that's for Teradata. Now, because I've worked on so many databases, right, I sometimes tend to forget as to which one is in which one. It takes time for me to remember that. So basically, metadata goes somewhere, data goes somewhere. Exactly similarly, in case of HDFS, the metadata goes to name node, the data goes to data node. Okay, so when we say name node, it's all metadata. When we say data node, it's only the data. Okay, that's how it stores. It maintains, manages, and administers data block present in data nodes. That's the task of name node. Data node, these are, and again, the architecture is such that everything is master and slave. Okay, name node is master, data node is slave. Job tracker is master, task tracker is slave. secondary name node does not fall onto master or slave. So everything is a master-slave architecture, and we call this as master-slave nothing shared architecture. There is no sharing between name node and data node. There is no sharing between a job tracker and task tracker as well. Okay, so data nodes are slave machines which provide the actual and redundant storage. Like I said, right, there is a replication factor. You know, each data is replicated into 3 different nodes. These are all data nodes. Okay, endpoints for client read and write operations. So data nodes are endpoints for read and write operations. I'm sure you know, while I'm explaining this, I might be a little fast for you, right? But then I'm just trying to give you a gist of thing. I'm just trying to intrigue you into learning more of Hadoop. And you can appreciate this fact that I cannot, even if you go and read the definitive guide, right, Hadoop, the definitive guide, which is 550-page book, you are not going to complete that in 1 hour, right? You will take at least a month to read that book. Now, that month of knowledge I cannot impart to you in just 1 hour, okay? But I can still you know, guide you to a certain direction wherein you can learn this. I can give you a direction, and I can show you the path from where you can pick up and then progress either on your own or with the help of someone. This is HDFS architecture. Basically, if you have any request from the client, I'm just going to talk about request. It goes through name node, and then from name node it gets the metadata, and inside name node there will be also a location where your data node is stored in your distributed file system. From there the data will be pulled, and the data does not go back, flow through name node to client, okay? It directly goes to client. So request goes via name node to the data node, but then retrieval happens directly from data node to client, okay? Client can be your own machine, your home machine, right? Your name node can be some other machine, XYZ, your server or whatever, whichever in your office, and data node also can be in office. So client machine is your laptop or desktop. Your name node and data nodes are, let's say, some 2 different other desktops. And you have this rack architecture, okay? Rack. If you have seen this, you must know a SU rack, right? Everyone has a SU rack in their home. Basically, those are partitioned wooden fittings wherein you keep your shoes in 1 rack, 2nd rack, 3rd rack, and so on and so forth, right? Similarly, racks are nothing but it's a type of almirah, okay? It's wherein you have multiple machines stored there or multiple CPUs stored there so as to process your data. So you can have multiple racks in multiple data center. Of course, all of your companies should have a rack. So mostly what we do is we keep rack in different geographic locations. Let's say, for example, if one is in Bangalore, another is in Mumbai, another is in US, we keep this in different geographical locations. So if something happens to one rack, we can still have data in some other rack, and which can be accessed on the fly. Okay, Google has its rack all over the world. So your request to Google, google.com will not go to San Francisco where they have the headquarters. It might go to Hong Kong, it might go to Singapore, wherever they have the data. But it does not mean the data is just stored in Hong Kong or Singapore. You know, it will be replicated in Hong Kong, Singapore, and maybe in San Francisco as well. But the reason why it's replicated in multiple places is because if one goes down, you know, you should not suffer because of that. And sometimes you might find that some of your searches might take a little time. Okay, one, it can be because of your bandwidth. Other can be because that. Okay, please close on any. Okay, guys, are you able to hear me? Am I audible loud and clear? Hey, Saurabh, Anantraj, Mohan, Ranjit, Ashish. Okay, thanks. Amit, Veda, Saurabh, Arun, Bharat, Siva, Niranjan, Koti, Srinivas, Divyagar. Okay, Krishna. Thank you, guys. Okay, I just got a message saying that some problem. Okay. Anyway, so basically, all I'm trying to make, the point that I'm trying to make here is data is replicated so as to be readily available. HDFS again keeps metadata in main memory. All your metadata, whatever you're trying to access, is stored in entire memory. Your file system metadata is not loaded from hard disk. Okay, so periodically, whatever data that you have in your name node, and let's say next question is, what happens when if my name node is gone? All metadata gone? No, it does not happen that way. In Hadoop 2.0, there is hot backup. You can have number of name node, or you also have a secondary name node, which is a periodic backup of your name node. So in case name node fails, you can go on to your secondary name node and then start from there. Metadata type. Now there is this whole concept. Okay, there will be downtime in case of 1.0, and then it has been bettered in 2.0. There's a big comparison, list of comparison between 1.0 and 2.0. But then let's stick to 1.0 right now because that's the most widely used version. That's the most stable version. Most people are using it. Most organizations are using it. So in 1.0, you have name node and then you have secondary name node. If name node goes down, you'll have a downtime. Okay, but then the architecture is such that it seldom goes down. Metadata type, files in HDFS, data block for each file, data node for each block, file attributes, access time, replication factor, access control. So a couple of things that you need to remember. You might ask me, what is metadata? Metadata can be the structure of a table, the location of the file, the date timestamp when it has been created, the access time, the replication factor, the access control, the modes, right? Read or write or execute. In Linux, you have all those, right? Change mode 777, if you know, or even in your Windows, right? You see right-click properties. Sometimes it's read only. It's sometimes write. Those are called as access modes. So basically, all this data are called as metadata. Secondary name node. I just gave you an example of secondary name node. It's not a hot backup, but it's a periodic backup. And saved metadata is used to bring up secondary name node. I've already explained this. Basically, from name node, there is a periodic backup here in secondary name node. Okay, it can be hard drive, it can be tape, it can be anything. Okay, MapReduce, I just gave you an example, right? If one person works on one thing for 100 and it takes 100 hours, if 10% works on it, basically it's more about estimation of work done by your project manager in their company, right? If your business comes and says that, okay, I need this project to be done in 3 months, right? And then your project manager says that, no, it needs 10,000 hours. So how is it that we can complete in 3 months, right? I mean 10,000 man hours. And then they will start dividing, okay, 10,000 hours divided by 10 person will become 1,000 per person. Okay, that's still not possible, right? 40 hours per week, it becomes 160 hours in 3 months. It becomes 16 3s are 48, right? 48, 480 hours. No, that's not possible. So 20% for 10,000 hours in 3 months, that's a possibility. So you say instead of 1 person, we'll add 20% to the project, finish that 10,000 hours project in 3 months. That's how estimation is done, right? That's how your project is built and stuff. Very similar concept here. If 1 person can do work in 100 hours, 10 people can do it in 10 hours. So it's the same concept with MapReduce. If 1 machine takes 100 hours, 10 machines takes 10 hours each, and then in 10 hours you'll be able to complete it. Find maximum stock market levels recorded in a span of 5 years. I could have shown this as a live example wherein I would pull the data live from some of the stock exchanges and draw a beautiful graph using big data and stuff, but because of constraints of time, I'm not going to do that, but it can be easily done. Okay, I'm watching time. Problem statement, de-identify personal information. Okay, banks always request for this, right? If you can see everyone's credit card, I mean, how many of us are working in banking project, right? Half of the world is working on banking project or insurance project. But then all those banking project, all those banking data will have credit card information, debit card information, so on and so forth, right? If all of us are given, free pass to get all those data, all those credit card information, there'll be mass misuse, right? So how is it that we stop that from being misused, the credit card information from being misused? What we do is we de-identify. We change the credit card number to some random numbers and give. So traditional solution is very big data. We split the data, we search the data, we match, and then we finally concatenate. That's the traditional way of doing it, right? We split the data, we search for the pattern that we want, we match it finally, and then we give it as an output. In case of MapReduce, we split the data, we run map and reduce framework on it. First, mapper is parallelizing. Okay, map means splitting of the data, reducers means aggregating the data. Okay, that's the MapReduce framework. And finally, we have all matches. You'd be like, how is this and this different? It's no different. That's what you'd say. I mean, by looking at it for a first timer, would say that, see, there's no difference. You just split the data there, you just split the data here, you just do a grep and match, but you do a map and reduce here. How is it different? It is different, trust me, and let me explain you that. See, in case of MapReduce, right, your input data is split into two different, let's say we have two nodes into two different nodes, let's say 100 MB, 100 MB. There's a mapper which runs on this data, there's a mapper which runs on this data, and then you have a key value pair. Finally, you have aggregation happening from all different mappers in one reducers, or let's say for example I have I need to do a word count. There are cats and dogs. 5 cats, 5 dogs here, 5 cat and 5 dogs here. So what it does is 5 cats goes here and 5 cats from here goes here, 5 dogs from here goes here, 5 dog from here goes here. Okay, there is this concept of all hashtags and keys, etc. Lot of concepts, okay, which I'm that's the whole different algorithm there where I'm not going right now. But then here, this is the concept, right? All the keys will be aggregated here, the different types of keys will be aggregated here, and finally you'll get your data in 2 different nodes. Finally, you'll get cat equal to 10, dog equal to 10 here. Now, see, word count problem in Hadoop is hello world program, okay? It's an hello world here. Okay, I've already explained about this data centers and stuff. What is expected in this section? We'll discuss the questions on HDFS and MapReduce. That's asked during interview. Okay. Finally, these are the questions that are normally asked. What's the use of name node in HDFS? What is data node in HDFS? Name node basically stores all metadata. Data node all the data, right? And job tracker will track whether each of the split data has completed or not. I mean, that's based on the information that is provided by task tracker. See, I'm using a lot of jargons right now. I'm throwing a lot of jargons at you. It's not to scare you guys, okay? It's just to give you an impression that, see, it's not rocket science here. And I'm not talking about anything rocket science. I'm neither a rocket scientist. It's a simple concept. All it needs is a little time and an effort. That's it, and you'll be able to do it. How does an application, Hadoop application, looks like on the basic component? So these are the type of questions that will be asked, and you can say there are 5 daemons here, and when you so on and so forth, okay? Job trends from Indeed.com, it's just going. There is a little rebalancing here, but then with the number of investment that's coming up, with the number of companies that are investing on Hadoop, this is going to just shoot up like this, okay? That's the forecast from Gartner, okay? Not my forecast. Doubts time, your chance to ask back questions and your doubts, your chance to take no doubts back home, one. And these are the course curriculum that Skillspeed.com provides. If any of you are interested, feel free to contact us, and we'll get back to you. So basically, week 1 we'll do introduction to big data and Hadoop, HDFS internals, Hadoop configuration, data loading. Week 2 introducing MapReduce, advanced MapReduce concept. We'll take you through Pig, we'll take you through Hive, and we'll take you through HBase and Uzi. Now Uzi is nothing but if you have worked on Control M, Autosys, all the scheduling. Scheduling tools, Uzi is one another scheduling tool, okay? It's interesting and very simple. So free trial of Hadoop and big data courses also you can get here. 3+ hours of training material will be provided to you, access to assignments and quizzes, real classroom experience. I mean, there are a lot of instructors, intelligent instructors who have like tons of experience, more than decades of experience, who will be teaching you. So it's a different experience altogether, okay? Basically, all we need from you is your time. That's it. How to activate your free trial? Please go to skillspeed.com and at least browse it, okay? You want to register it, you do not want to register, it's up to you. But go ahead, see how the courses are being taught, and just have a look and feel, And there are many options to learn. I mean, if this is just one. So basically, why Skillspeed? Course curriculum from industry experts. This is what you get. I mean, people are really experienced. They bring actual experience to the table. I mean, I've seen people being taught. Okay, I resent the fact that if you don't know a subject, you rather not teach it. I go through many Tech Geek sessions and try to find out as to what different people are offering. And sometimes I'm pained to see that people who do not have so much of experience are teaching something. I mean, teaching is a very noble profession. That's what I believe. And if someone is teaching it, you rather be honest to your profession. Okay. Instructor live virtual training. The training is going to be like how we are discussing right now. The reason I'm not able to take all your questions is, you are like almost 100 people asking questions at me, right? So I cannot take all your questions right now. But then whenever it comes to class, right? Only 15 to 20 people are allowed in one class, and everyone's questions is attained. We do not have too many people in class so that it's clogged. Okay, and where is that? Okay, not this one. Okay, and then we'll also provide you 100% placement assistance, lifetime access to course. Once you have logged in here, you'll have lifetime access to course and support from our support team, and 24/7. Okay, to know more, please contact this. Lines open 24/7. You'll also be sent this PPT. You can have a look at it. You can contact us anytime you want. And last but not the least, okay, I'm not trying to sell anything to you, folks. Please be rest assured that I'm not trying to sell anything to you. It's totally up to you. You like it. If you want to learn it, there are ways in which you can learn it yourself, right? No one has to feed you, spoon feed you. But we, as a team here, would just provide you direction, and that's about it. You know, we cannot spoon feed you. And if you are really interested in learning, you'll just open the books and then you'll study it yourself. But then you might need help at times. You know, that's all we are going to provide. We are going to take you through the basics, and we are going to help you in certain way that, you know, you will be successful. You'll come out successful. You'll be able to you know, understand Hadoop with much deeper and clearer concepts. These are image references, guys. That's all. Thank you very much. I am dot on time. I've exceeded just by 1 minute. Parsing XML data using MapReduce. Yeah, so Survi, it's simple actually. I can show you parsing XML in you know, just using MapReducer, using Python. You know, I can write 4 lines of code in order to parse an XML. So it's extremely interesting, actually. Yes. And guys, yeah, Divyagar, Rami Reddy, why replicated difficult to 3, not 5, 7, etc. It's up to you, Rami Reddy. Simple thing is that how much ever resource you have, you can replicate it to 5, 7, but ideally by default it should be 3. Okay, that's a standard number that's given. Yeah, Balaji, that's right. If you use different nodes having different computing capacity, your performance as a whole might go up. Let's say, for example, to process 100 MB of data, one machine is taking 10 seconds and another machine is taking 15 seconds. So your aggregated time will be 15 seconds completion of the process, okay, or data processing. But then Krishna, yes, people are saying that Apache Spark will overtake Hadoop, which is 100x faster. But what's Apache Spark? Internally, it's all MapReduce, right? Which does in-memory operation. So until and unless you understand map and reduce, how are you going to learn Apache Spark? That's the basic of MapReduce. Apache Spark, you know, MapReduce is the basic of Apache Spark as well. Yep, Pranav, you can do that. Just shoot an email to our support staff, and you'll definitely get my guidance. Absolutely. See, if the name node goes down, yes, we definitely have a problem. But then the architecture is such that, and the algorithm is such that it does not go down. Even if it goes down with Hadoop 2.0, we have a hot backup, a standby name node. Okay, if one name node goes down, there is the other one which takes over it. Okay, and then you have secondary name node from which you can rebuild the name node. I mean, there will be some downtime in case of 1.x architecture, but then you'll be able to retrieve everything. No, I mean, none of the Hadoop technologies will provide you real-time analytics. I mean, when we talk about analytics, we don't talk real-time. I'm not sure as to if I get your question correctly, Amit. Okay, okay, here you go, Raghav. Sure, Pranav, no problem. It's all my pleasure, man. How can we implement analytics in Hadoop? That's a big, wonderful question that you have asked, Prasanna. So mostly Hadoop is for analytics. It is for processing data, and finally, it's not only with Hadoop that we do analytics, right? It's we use Hadoop in order to you know, cleanse the data, slice and dice the data, bring out proper data on which we write our machine learning algorithms to do analytics on top of that. Can we use? Absolutely, you can. You can use NoSQL DB. Yep, Amit, you can do that. Prasanna, I would love to do that, but I'm sorry, I've really run out of time. Okay, you can send me an email. Just send me an email, and I'll send you some reference material on which you can have a look at it. Okay, SNN. Nearest neighbor, right? Okay, single name network has last snapshot of the data only. Okay, sorry, secondary name node. Okay, it has last snapshot of the data. Yes, you might lose that data from. Yeah, you're right, Rami Reddy. You will lose the data. Let's say I have every 10 minutes backup, right? I might not have that 10 minutes backup, and I might lose it. I'll have to go to that point back in time and then process the whole data. JSP, right? Is it possible to write Java servlet pages code in Hadoop? Using Java, you can write JSP. I'm not so sure. I've not written code on JSP, Divya. Okay, guys. Oracle and Hadoop is not at all related, Balaji. You can use that. Why can't we use Zookeeper? Okay, Zookeeper is for high availability. I'll have to explain you the whole concept of Zookeeper and Scoop, Divya. No, you don't need, Santosh, you don't need to learn. Yeah, I got that, Divya. I know JSP, but I have not used the JSP in order to implement Hadoop. That's what I said. Okay, guys, I think we have run out of time. I would love to answer all your questions. Just send me the list of questions. Okay. Yep, Prasanna, no problem. Thanks a lot, Raj. Okay. So I'll take all your questions. Just send them all to our team here, and I'll respond to each of you personally. Okay. Thanks a lot, guys, and I'm extremely sorry. I apologize for not having able to. You will get that. You know, we'll send you via an email, Balaji. Don't worry about that. You'll get all the email IDs. Okay, and I'm extremely sorry. I apologize humbly for not having able to answer all your questions. Okay, but definitely send me your questions, and I would love to help you guys. Okay, Niranjan, it's my pleasure, man. I mean, if I'm able to help you guys, if I'm able to help you inspire, learn something new, and help yourself, that's my achievement. Okay, thank you. Absolutely, Rami will be sending our PPTs as well. Santosh, do send me an email. We will first send you an email with the presentation. You have a look at it. You can get back to us, and I'll respond back to you. Okay. Thanks for the. Okay, no problem, Ankit. Thank you, Bharat. Thank you, Kiran. Thank you, Santosh. Thank you, Veda. Take care, guys. Thank you, Santosh, Joeb. This is recorded, Joeb. You'll get it. Okay, you'll get the link. Thank you, Balaji, Divya, Surabhi, Ankit. You will get the presentation, you'll get my email ID, you'll get everything that will send in an email to you, okay? Because when you registered for this, you gave your email ID to us. We are going to get back to you on the same email ID. Thank you, Ashish. Okay, guys, take care. Bye-bye. Thank you, Ankit. Thank you, Ranjit.